he wants his tessellation to include 18 rows. How many additional toothpicks will be needed for the 18th row? This is for the 18th row only. On the test, there will be questions, as you have seen, that are just talking about only one row, or adding another, like, hey, what happens if you're in the 18th term? Whereas this question says what? How many toothpicks will Polly need for the what? The tessellation. This is talking about the whole picture. What do we call that when we need how much we need for the whole thing to happen? Towards the end of yesterday's lesson, what did we do with all those numbers? It's a series where we added the first row to the second row to the third row to the fourth. You guys got what I'm talking about? Because I would need, how many toothpicks do I need for the whole tessellation? So that would be a series question. This right here is not a series question because look, it's saying how many toothpicks will he need for the 18th row only. So in this one, you're looking for the 18th row. This one, you're looking for the total object. Do you see the difference? No one's going to tell you that on the test. They're both going to be on the test. You've got to know how to know the difference between the two. Are you with me? Yes? Good. So for this one, it should have done, our formula was 2n plus 2. So n represented 18 for this one. So you should have done 2 times 18 plus 2. We did that in class. 36 plus 2, 38. For this one, what do we know we'd have to do? What did we say? Because it says don't actually do the calculations. What would we have to do? We'd have to add every row together up to the 18th term. Are you with me? Except, now what do we know? How do we solve this? What would we use? Whose formula?
Gauss.
We would use Gauss's formula, which says n times a1 plus an divided by 2. That would give us how many toothpicks we needed for the whole tessellation. What would be in this case, if we were actually going to do it? We're not going to, but if we were, what would we put in there? What would be a1? What's our first term of the sequence? 4 plus, what's our last term? What did we find out for the 18th row? How many toothpicks did he need? 38. We found that out right up here, right? Divided by 2. Hopefully you know how to add, multiply by 18, and then divide by 2. Make sense? Alright, this one right here, for part B, it says the summation of just the first term. Well, what's the first term? 3. That's all you're going to do. You're not adding anything with it. It didn't say the first and the second term. It just said the first term. So, in order to make the first row, or that, whatever we're doing, I just need 3. For the next one, S7. That means I'm going to go from, I'm going to add the first term, plus the second, plus the third, plus the fourth, plus the fifth, plus the sixth, all the way to the 7th. So really, I'm just adding all of those together up there. When we add them together, what'd you get? 381. Questions? This one right here, use sigma notation to represent the toothpicks to complete 5 rows. I'm just throwing this out there. This is not sigma notation, but this is what they wrote here. We would write that as S5, correct? The summation up to 5, and in sigma notation, what would that look like? Well, let's give them a sigma first. I equals what?
1.
And then goes all the way to?
5.
And A, I. No, the sigma notations they're looking for. And if I wanted to find this, actually the answer out, because they said that they want us to actually calculate that out, we have to add 4 plus 6 plus 8 plus 10 plus 12. Is that the final one? And when you did that, you got 40. Is that the answer? All right, now we went to Gauss. It's not spelled the same as Gauss. That's using your mouth, I guess. And he did something we found out in 6th grade. He did Is anyone in chemistry or something? Or is it, I don't remember, Chase told me. He's going to give him a shout out. He said, was it physics or something? It was a Gauss law, something. Anyways, it's the same dude. Not only did he do stuff in math, but he did stuff in science. So we got A says now we're actually supposed to find that same question that we just did for homework. We're going to find the same amount, but we're going to use Gauss's formula. So how many toothpicks should we need total for this? What should the answer be? It should still be 40. We're just finding the 40 a different way. With me? So it's n. Right here, if I use this formula, n. What is n in this question for A? 5 times A1. What was the first term? 4 plus, what was the 12? Divided by 2. This is 16. I don't know 16 times 5 off the top of my head, to be honest with you. I could figure it out, but it would take a lot more brain power than I want to use. So here's some mental math that I'm trying to show you what I do. How can I rewrite? This whole thing is divided by 2. What can I redo that as? Can I do times by a half? Does everybody see that? The only reason I can do that is this is a plus sign. If I had 4 plus 12 divided by 2, I could not rewrite that as 4 plus 12 times 1/2. That would not work out. Why? This is actually included in parentheses, and this is addition, and I have to add this first before I can divide by 2. You guys get what I just said? So I could rewrite it as this. I could rewrite it like that. That would work. But why can I rewrite this one? What is the 5 doing to the 16? Multiplying. And what did I make the 1/2 doing? So they all have the same power. You guys get what I just said? Whereas before, the addition and the multiplication don't have the same power when I'm talking about order of operations. So now, I can cut the 16 in half, which is 8. And 8 times 5 is 40, and I know that much easier in my head for mental math. I know how mental you guys are, so I'm going to help you out. Good? All right? For 18th row, we already set that problem up just a second ago, didn't we? N was 18. First term is 4. 18th term is 38. Divide by 2. And when you do that, how many toothpicks did you guys get?
378.
378. Does he have enough toothpicks? No. He's got 350. He needs 378. He does not have enough toothpicks. Is that it?
Yeah.
Is that for the homework? What else do we have to do? What?
3.
Calculate the sum of the first odd whole numbers, then verify result using Gauss. What was that formula that we came up with then? Did we come up with a formula for it? Alright, so this one I told you the answer was 10,000. You're just supposed to make sure you can get to that. If you need help, let me know. I'll pause the video and go over it. Alright, moving on. 6-3. Alright, the thing about 6-3 is now we are changing to a geometric series. If you think about geometric series, the way that we get to these guys is we use a common ratio. Whereas when we're in a arithmetic, we used a common difference. One you are adding and one you are multiplying. These two will not have the same formula to calculate their series. Now, is the process still the same? Yes. Like, if I give you a sequence, but it's geometric, and I ask you to calculate the series, you are still adding the terms together. But do you remember Gauss's formula? Gauss's formula only works for arithmetic series. It will not work for geometric. Do you guys get what I'm talking about? So when I ask you to calculate a series, what's the first thing you need to decide?
We're going to start.
Where you're going to start is it geometric or is it arithmetic? Because depending on which one it is, you're going to use different formulas for the two. You get what I just said? Do not use the same formulas. Gauss's will not work for geometric. We're going to come up with a new formula. Right here, we're going to go through this pretty quickly and see if you see a pattern. So Paul says, hey, add all these together. And notice, how do I know it's a geometric series? Got a common ratio times by 3. Yes? All right. So if we have these series, you're going to add them together. Same kind of thing, but here's going to be our pattern of the formula we're going to use for it. We're going to try to come up with it first, and then I'll actually show you what it is. So you guys see, Teresa is going to answer how you add these up together. Notice what she does. She multiplies 729. Where do you see that? Where do you see that in the sequence? It's the what? The last term. She multiplies that by 3. What did we decide that 3 was? Our common ratio. So she's got the last term times 3, then she subtracts 1. We're going to see, we'll wait on that one for a second. Then divides by 2. With me? She takes the 5,120, known as the what? Last term. You guys with me? Multiplies it by 4. Well, what's that? The common ratio. Subtract 5. It's the first term, right? What was 1? My first term. What is subtract by 10? It's my first term. Now this one's a little trickier. How did she get 2, 3, 5, and negative 3? I'll give you a hint. Look at the common ratio. What's 3 minus 1? 2. What's 4 minus 1? What's 5 minus 1?
4.
What's negative 2 minus 1? So, here's the formula, just written out in layman's terms. Just showing you how to, kind of where it came, like a little bit about it before we did it. Here's the actual formula. You take the last term, times it by the common ratio, and minus the first term. You divide by the common ratio, and that's how you find a geometric series. How many things do you need?
4.
4? Or is 1 used twice?
Oh.
You really only need 3. You need the last term, you need the common ratio, which is used twice, and you need the first term. So every time I'm going through these and I'm actually going to add them together, that's all I'm looking for. Are you with me? So here we go. I want you to try A and B on your own. I think you guys should be able to plug in. What are the 3 things I need to decide?
Common ratio. First term.
Let's go for the first term first. Does everybody see that's my first term? What is this right here?
Last term.
My last term. Now, what's the trickiest thing, but it shouldn't be too hard to find? How do I get from here to here? Remember, since we're in geometric, it's always what? How do I get from 1 to 10? And check it. Does times 10 get me here? So my common ratio is 10. I'll let you do B all on your own. Now C, we're going to do a little bit of with it because it's kind of a new way that we've written. This is in summation. This is in that sigma notation. What term am I going from? I'm going from 1 to what?
8.
I'm going from 1 to 8. And here is how I'm going to find my terms. So what is my first term? My first term says I take K and I plug in what? 1. 1 minus 1 is 0. What is 5 to the 0 power? 5 to the 0 power. Anything to the 0 power is 1. It's an algebra rule.
Oh,
It's kind of cool. How do I find, and do I really need my second term for this? What are the three things that I need? First term, last term, but I'm going to find a couple more terms just to show you how to use this thing a little bit more, just to be a little bit familiar with it. If I wanted all the terms, do you get what I'm saying? So how do I find my second term? What do I do? I put a 2 in for, okay, what's 2 minus 1? What is 5 to the first power? So 5 is my second term. How do I find my third term? I put a 3 in for, 3 minus 1 is 5 squared is 25. Do you guys see how I'm getting? This is first, second, and third term. And then I can do a little dot, dot, dot. What do I really care about, though? What's the one I really need for what my problem is? I need the first term, and I need my last term. What's my last term going to be? K is going to equal 8. 8 minus 1 is, I'm going to leave it as 5 to the 7th. I'm not going to multiply that all out yet. I'm going to hold off on that. It's a monstrous number. I'm going to let my calculator do some work when I get there. Everybody okay with that? What does my formula say that I have to do? What's the formula say?
A1.
No. Last term, the one we just did.
Oh, yeah.
Last term, 5 to the 7th power. Which is, what's my common ratio here? How do I get from here to here? Times 5. Check it. Times 5 works. So my common ratio is 5. Minus what? No, okay, yep. Minus the first term, which is what? 1. All divided by 5 minus 1. Everybody okay with that? What happens when you have a number raised to a power, but these guys have the common base? What can you do with their two exponents? Add them together. Is this one going to be written in there for me? Who had to write that in there? I did, because I have to know that that's there. And 7 plus 1 is 8. So 5 to the 8 minus 1 divided by what? 4. 5 minus 1. Now I'm going to take my calculator out and let her do the work. 5 to the 8th, then minus 1, and then finally divide by 4 at the end. And if I do that, I get 97,000. 656. Does that make sense? I want you to try D also. I'm going to help set up a little bit. So it's a sequence with 9 terms. That's a big deal, right? And it says the common ratio of 2. By the way, what do I need in order to find the series? For geometric. First term, last term, and what did they give me here? That's one thing. What did they give me here? 2, right? So now I just need the last term. Are you following me? How can I figure out the last term? Well, I know it's going to be my 9th, right? So I need that explicit formula from 6.1 for geometric, which in geometric it says it's the first term, which is 3, times the common ratio, which is 2, to the n minus 1 power. Do you guys remember that? Yes? So then I get 3 times 2 to the 8th power. I put a 9 in for my n. And 9 minus 1 is 8. So what would I do in my calculator first? 2 to the 8, and then times it by 3. That's going to be my last term that I'm going to use for my formula. Do you guys understand what I just gave you? Do you have all the ability to now finish this problem up? You should. You have everything you need. Once you calculate that, that's your last term. Yes? Alright, so with geometric series, you do have to be kind of careful with them. Do you see how right here, it says there's number of terms is 3. Do you see how this says there's a number of terms is 4? How does this one, how can it be written like this or this? Do you see where I equals 0? Do you see where I equals 0 for that? That means that you would plug in 0 for I. So right here, in this one right here, what would I plug in for I? I would plug in 1, 2, and 3. And so you see how I get 3 different numbers. With me. Well, in this one, what would I plug in? I plug in 0 for I plug in 1 for I, and I would plug in 2 for I. How many terms do I still get? 3 of them. Why is this kind of weird? Because you're using 0, and so we don't normally count with 0. So it's not a counting number. Remember, it's not our natural numbers. So this is one term. This is the second term. This is the third term. It's just a different way of writing it in here. Here, why? What happens right here? What does this really eventually turn to since I have that -1? When I plug 1 in, what does that really turn to? 0. Whereas this one just uses 0 right off the bat. You see what I'm talking about? Either form works. Identify the number of terms, the common ratio, G1 for each series, then compute. So right here, let's do this one. What is the number of terms? How many terms are there in A? Does everybody see how there's 5? 1, 2, 3, 4, 5. What is my common ratio? Well, what is, the first term is 1. The second term is 2. What's the third term? 4. 2 times 2, right? So 4. So how do I get from here to here? Times by 2. Times by 2. So what's my common ratio? 2. How would I figure out my, because it says, then, G1. What's G1?
1.
My first term, which is 1. Now it says then compute the series. How would I do that? That's the one where you do the last term times the common ratio minus the first term, all divided by the common ratio minus 1. So you could do that for homework. You should be able to do B for homework. And you should be able to do C. Now, real quick, before you leave, do you see how this is changing right here? It's going from positive to negative to positive to, what do you know your common ratio is going to be? Negative. That's the only way that it could change signs and flips like that. All right, there's another formula that we can use to compute series for geometric, and we're going to talk about the difference between them, and that formula is right here. Formula is right here. We're going to talk about the difference between Euclid's method and this other method that's right here. So if you look, this guy right here, you need the last term, you need the common ratio, and you need the first term. That's what we've talked about so far in class. But now we've got this new formula, which says you need the first term, you need the common ratio, and you need the term number, and that's all you need. So if you look, there are two different formulas that need three different things. This one needs, like I said, the last term. I want to make notes on this. Common ratio. And you need the first term. So if I give you a question and you have all three of those, or it's easy to find these three, then you want to use this formula. If I give you something and it has the first term, it has the term number, the last term number, and you have the common ratio, then you can use this formula. So let's go ahead and try some examples like that. So number 6, the question asks, when is it appropriate to use each formula? That's what I just answered right above those things where you have this and this and this. Alright, so we're going to rewrite using sigma notation. So we're going to talk about sigma notation again, what we need. So if you remember, sigma notation is like this right here is what we're looking for. We're going to do it a couple ways just to make sure we understand what each of these stands for. So first, let's start with the sigma. 1, 2, 3, 4, 5, 6, 7. So I've got 7 terms. So I have two options. I can go from I equaling 7, or 1, sorry. And if I equals 1, then I need to go all the way to 7. Now the other way, which the reason we're doing this is because of an example like B, is I can write this as I equals 0, but if I go down 1 here, I have to go down 1 for the 7, so it makes it a 6. Because remember, we're actually using 0, 1, 2, 3, 4, 5, 6. And if I count that on my fingers, that's actually 7 terms. Whereas this is 1, 2, 3, 4, 5, 6, 7, and that still gets me 7 terms. So both of these two guys right here are equivalent. Now, the thing I need also is I need a first term. Well, my first term is 64. And if you remember, the explicit formula for geometric is the first term times the common ratio. The common ratio here is going to be, how do I get from here to here? It's actually, I'm timesing by a half. Remember, we're dividing by 2, but we can't write it using that, so we have to do times a half. And then, if you remember, this is going to be I minus 1. Because remember, we're going to be taking all these, plugging it in. And you can check to make sure that this works. Because if I plug in 1, 1 minus 1 is 0. Half to the 0 power is 1. Remember, anything to the 0 power is 1. 1 times 64 is 64. Try the next one. Take a 2, which should get me to 32. I take a 2, plug it in here. 2 minus 1 is 1. Half to the first power is 1. 1, so 1 half to the first power is a half. Half times 64 is 32. Now I'm going to write the next one down to just show you. 64 times 1 half to the 3 minus 1, should be half, turns into 64 times 1 half to the second power. That really means, right here, that really means you have half times a half, which actually equals 1/4. So you have 64 times 1/4. What does that really mean? That really means you have 64, top times top, bottom times bottom, divided by 4. 64 times 1 is 64, 1 times 4 is 4, 64 divided by 4 is 16, and that's how I came up with my third term. So I can check and make sure that that right there gets me all these terms right there. And the other way I can write that, remember, if I start at 0, then all I have to take off is I do not have to include that 0. So what I can do, I don't have to include that right there. So it could be just 64 times 1 half, and now instead of doing I minus 1, I can just throw an I up there. Because when I first plug in, I'm going to put I to the 0. So 1 half to 0 is 1. 1 times 64 is 64. I put a 1 in here, 1 in here, then that becomes half to the first is half. Half times 64 is 32. So again, I'm checking and making sure I'm getting these numbers out. Alright, so for homework, I would like you to try A, and I would hope that you would try to do both ways. You should try to write both these down because they're going to be different ways that you can see them on the test. By the way, the 64, just so you know, can actually be written like this. Your first term, you can write summation like this. 64, and then summation, and then I equals 1 to 7, and then put your 1 half to the I minus 1. The first term, you can move that out here. That has to do with the rule for sigma notation. So So if you notice, just the 64 can be moved out in front. And then the reason I'm saying that is like problem number B, or letter B. So practice that too, maybe for A. Maybe try to pull out the first term in front of it. So, and we'll go over that in class. So for number 8, we're going to try both ways. We're going to try both formulas that we've learned. The first formula that we're going to try is the original one that we know, which is Euclid's, which says that we need the, so Euclid's, just so you know, is the last term times common ratio minus the first term, all divided by the common ratio minus 1. And then that other one, it's Perry's who used it, but we're going to say it's just summation. The other formula is where you need the first term times it by the common ratio to the nth power minus 1, and then divide that by the common ratio minus 1. So we're going to do both formulas in here just to see how this works out. So for Euclid's, I need my last, I need my common ratio, I need my first. So let's get that. So my first, my G1 is, if I do this, remember I plug in, my first term is when I plug in this number down here, which is 0. 3 to the 0 power is 1. And then you take whatever answer you get in here and you times it by 10. And so 1 times 10 would be 10. So hopefully you see how I got my first term to be 10. That's that new thing that they're showing us for this is a way that you can write that. If you wanted to, you could stick that inside. This is the same thing as this. I to the I0 for 10 times 3i. Sorry, 3. It's the same thing. So again, you just plug 0 in here. 3 to the 0 is 1. 1 times 10 is 10. So that's how I got my first term. My next term is going to be, next thing I need is the common ratio. Hopefully you see that that is 3. That's going to be whatever you're raising to the power. So 3 is my common ratio. And my last term, which is going to be 4. You should get 4 for this one. And actually, if I wanted to know, there's actually going to be 5 terms for this one. Remember, 0 is counting. So 0, 1, 2, 3, 4, 5. So actually, this is my 5th term. Just to, well, we'll need that for maybe this one right here. G4 is going to be where I take 3, or I, and I put a 4. So 3 to the 4th power. So if you think of that, that's 3 times 3. So I do 3 times 3 times 3 times 3. That's a 9. That's a 9. That's a 81. And then I take that 81 and times it by 10, so I get 810. So for Euclid's, I take the last term, 810. I times it by the common ratio of 3, and I minus 10 from that. And then I divide by 3 minus 1. So I put my calculator, I do 810 times 3, and I get 2,430. I minus 10 from that, I get 2,420, and I divide that by 2 in my calculator, and I get 1,210. So that should be the answer. Now I can try it the other way. Now I'm going to try using this formula, and I should get the same answer. So if I try the other formula, I need G1, so that's 10, times the common ratio, which is 3, to the, now this is the tricky part. The nth power is going to be, what term is this? It is not the 4th term. I know that that has a 4 there, but remember, I started counting with 0. So if I count with 0, I got 0, 1, 2, 3, 4. These are all the things that are going to go in for I right here. So if I count, that's 1, 2, 3, 4, actually 5 terms. So my n for this one is 5. So it's 3 to the 5th minus 1 divided by the common ratio, which is 3 minus 1. Again, I use my calculator, And so when I do 3 to the 5th power, that is going to get me to the answer of 243. This is 243. I minus 1, and I get 242. I get 10. That's 242. All divided by 2. And when I do that, I get my answer of 1,210. So again, they both got me to the same answer, just different ways and different formulas. So please make sure you try both of those. I would like you to try A for homework and C for homework. All right, have a great weekend. Appreciate it, guys.